15 divided by 3, we know the answer is, okay, go ahead and write that down. Now, on 1/3 times 15, here are two ways to look at it. 1/3 of 15, which would look like this. Okay? Or, and this is the easiest way for me to think of it, 15 copies of 1/3. So if I do 15 copies of 1/3, of course I don't want to write all that, do I? Keep it going, okay? What's my denominator going to be? 3. And what's 1 plus 1 plus 1 plus 1 15 times? 15. So for this, it's easier for me to take my numerator, look at the board, times the whole number, and then divide it by the denominator. So what's 15 divided by 3?
5.
5, we just did it. Okay? Now, the next one's different because instead of 1/3, what do we have? 2/3. So we would have 15 copies of 2/3, or we would have 2 of these filled in. So 2 of these filled in is what? Well, we know one of them was 5. So what would 2 be? 10. Okay? So remember the way of multiplying the numerator times the whole number? What's 2 times 15, Chloe?
2 times 15?
Go ahead and say it. 30. When I add fractions or repeated addition, does my denominator change? No. So is the answer 10? It is. So 15 copies of 2/3, the answer is 10. Okay, let's go across. No, let's go down. 18 divided by 6. 3. Okay, so now I could draw a tape diagram with 6 boxes and figure out what number goes in each one. Or I can take 1 times 18 divided by 6, and my answer is 3. Remember, boys and girls, this fraction line is a division sign. Okay, so on this one, how does it change?
It's 5,
5 times 18. I don't know that in my head. So I'm going over to the side, and I'm going to multiply to figure it out. Okay, everybody got that done? Why didn't you do it? I'm not doing your work for you. What's the denominator? 6, and it does not change. 90 divided by 6. Does anybody know it in their head?
30.
You're on the right track.
35.
What's 30 divided by 2?
15.
Okay, so take a look at this. It's one that I have memorized because I visualize it, but I know that 15 times 6 is 90 because 15 times 2 is 30. 30, 60, 90, 2, 4, 6. So the other way to figure that out would have been a simple little long division problem. So the answer to 90 divided by 6 is 15. Is this the same problem?
Yeah.
Commutative property of multiplication? Okay. It's just a different way to say it. We would say this one, 5/6 of 18. We would say 18 copies of 5/6. We get the same answer. Okay? Now, let's practice these. So, my strategy here would be to draw a tape diagram and put 8 boxes in it? No. Do it numerically. What's 1 times 32? 32 divided by 8.
4.
Okay, sit up. Don't lay down. Same thing. How's it different here?
By 8.
I don't know 32 times 5 in my head, so I'm going to figure it out, and so are you. What'd you get?
160.
So 160 divided by which number? 8, the denominator. Jesus? How am I going to figure this out? 16 divided by 8? And add a 0?
Yeah.
Okay, so what is it? 6.
Oh, 2.
2 with a 0 on the end. 20. Good. Okay?
Maybe 2 zeros?
No, there's only 1 0 on 160. See it? So I took the 0 off to do 16 divided by 8, then I put the 0 back on. Okay. This one, 2 times 18. Does anybody know it?
2 times
36. Good. So 36 divided by 3.
12.
Wow, that was fast. Okay, I don't know 24 times 3. So I'm just going to do it real quick. Some of you are very good at mental math, and you can do that in your head. So 72 divided by 4. I don't know that in my head either. So I'm going to do a simple long division problem. Take a look at this. So only one group of 4 could be made out of 7, right? 4 times something equals 32.
8.
8. So what's my answer?
18.
18. Okay, some of you are just kind of zoning and not actually writing and listening and focusing. You need to, okay? All right. So let's take a look at this. This is a review of area. So go ahead and work through these, and I'm going to pull sticks for kids to come and write it on the board. I think I'm going to pause it while we're writing it on the board. Okay, check your answers with the ones on the board. Make sure you've got them right. 7 times 4 equals 28 yards squared.
No, 12 times 3.
12 times 3, yep. Okay, next. We've got a review of volume, but you don't have to build these, boys and girls. You're just going to count and fill it in. Think you can handle that?
Yeah.
All right, so check your answers with the ones on the board. That's a review of lesson 1, okay? All right. So for the application problem today, I gave you a few dots. These dots are not going to include a tower that's 12 high, and I don't know if you could get 12 across on there either, so don't build those, okay? Mike uses 12 centimeter cubes to build structures. Use centimeter cubes to build at least 3 different structures. I'm still reading. 3 different structures with the same volume as Mike's. Record one of your structures on dot paper. Okay? Make sure your corners match up on your structures. I'm giving you 4 minutes to do this, okay? Yep, get your cubes. Okay, so right now I want you to get your regular pencil and draw one of those structures on the dot paper. I'm going to draw one that Madison made this morning. I thought it was kind of cool.
Can we draw yours?
No, you draw one of your own, please. so let's look at the first problem we're doing today, and just put everything down and let me read this to you, and then we'll talk about what it's going to look like, okay? So it says to make a box. Now today we're going to make a box without a lid. And I've got an example of the first one right here. It's going to be this big, and it's just going to be a box, okay? I traced it with marker so you could see it from a long ways away, but you're going to use colored pencils. So do you see where I made these diagonal lines? Just shade it, okay? So it says, copy this image on grid paper by first shading the bottom of the box. What's the bottom called, boys?
The
base. The base, okay? So shade the base and then trace the rest of the lines. Cut it out, okay? Fold it. You're going to crease it and fold it. And you see how I have the colored part on the outside of my box? Okay? This isn't a cube because it doesn't have a top, okay? Then you're going to fill the box with cubic centimeters to find how many cubes fill up the box, okay? Those are the directions. So I'm going to show you where on the grid paper to draw this so that you have enough room, because we're going to draw 3 different shapes. All right, so what's the most important part of this figure? The sides or the base?
The base.
The base. Once you get the base, then you can build the sides. This side is how many layers? 2 layers, okay? This figure is hard to imagine the volume of. But once you make it and you fold it, then you can see what we're talking about, okay? So the next one, if you didn't get your prediction right on this one, the next one you probably will, okay? So here's the second one we're going to do. Make another box, do it the same way. On your paper, on your grid paper, go ahead and use the rest of the top if you have enough room on the top to make this one, okay? And make your prediction in your head, then check it with the actual centimeter cubes. Okay, so we're getting better at predicting. How tall was this structure? 2 layers. 2 layers or 2 stories, okay? All right, we got one more. So this time it says, put the first layer of cubes on the bottom without actually cutting the box. And then what do you think the volume will be? So if you have not folded it yet, just put the first layer of cubes on and see if you can figure out the volume, okay?
Can I use one of my boxes to put?
So on this one, what was this base layer? How many were in it? 16. And how many layers tall was this figure?
3.
So 16 times 3.
48.
48. Did anybody get that right to start with before you ever did it? Okay. This right here, look, boys and girls, visualize this folding up. So that is how tall it is. This is the base. So it's going to be the base times 3. Are you listening? It's going to be the base times the height. How tall is the figure?
3.
3 centimeters. So it's going to be the base, 16 times 3 equals 48 centimeters cubed.